Hello everyone and welcome back. So in this module we are going to continue our discussion on recursion and see specifically how recursion can be used in searching and sorting algorithm. So let's get started. The very first algorithm which we are going to discuss is going to be linear search, something which we have done iteratively before, but I want to still discuss how it can be done using recursion. So let us see about linear search. In linear search, as we are aware, we were given an array. So let me write linear search here. In this, we were given an array or a list, and we have to actually find an element. Let's say that element is x and tell if it is present or not, right? The same can actually be asking for a position, but of course that variation is easy to do once you understand the linear search. When we were doing the same using iteration, we used to just go to each and every element and see if that is equal to x and return true if it is, else we used to return false in the end, right? The same thing to do via recursion. Of course, we have to follow the steps of recursion. So let us see what are they going to be. Now the very first step, it's actually going to be the base case, which we are aware of. The understanding on applying recursion is going to be the same as I've told you to apply recursion using PMI. That falls on all the questions. So make sure that you are just applying that framework and you will be able to write the solution, right? So base case is the first step. Now I personally feel that base case can actually be when our array is empty. Okay, so no elements are there, because then of course we cannot find anything, right? So if length of my say L1 is 0, then I can just say that you can return -1. So I'm taking -1 if we are not able to find. The same thing when we do using the indexing, right? So if you remember in the last question, when we were finding first, last and all these indexes of a number, we were actually using the concept of passing an index as a variable, right? As an argument in our recursion function. The benefit of that is we don't have to create copies of list. In a similar manner, if my L1 is going to be equal to index, then also I can say that we have reached to the last of array or to the end of array and we have not find it, and we can return -1, right? So that is going to be the base case. Now let's talk about induction hypothesis or recursive call. Recursive call, I believe, is pretty easy. Like we can just ask recursion, okay, we can just ask recursion to go and find the same. And we have to assume, again, we have to be very much sure of this step, that we have to assume that we are going to get our answer. So if we are following using indexing, we can just pass by index +1, and let's say if linear search is our code, and give the L1 as well. And we should assume that, okay, it's going to get our answer. Okay, so in this particular question, we are making sure that we are returning our answer. I've already discussed in the last module about what are the different variations of printing our answer, returning our answer, adding the answer to a list, and all these steps which are actually asked in different recursion question. So the second one is going to be a recursive call. And the third one is actually going to be our work, wherein for one of the elements, okay, so it can be even either the last one or the first one. We normally take the first one. We will just check if this is equals to x, if this particular element is equals to x, and if it is, then of course we are going to return true, or else we are going to return -1, right? So let's see the same in code as well, everyone. So let us do linear search first. So def, I would say linear search using recursion. Please make sure that all of you are actually drawing the recursion tree and doing all the steps. In the initial question, that is of very much importance. Okay. So now let me call this on some example. Say 1, 4, 3, 2, 6, 7, 8. Okay. X, let's say we can take it 2, and index initially will be 0. Okay. So I hope now we have done lots of questions, so you all will be a lot comfortable with this calling using the index. Now our answer is something going to be, which is something we are going to get. Okay. And we can just print our answer in the end. So let us write our base case first, everyone. Let us write our base case. The base case is going to be if L1 of L1 of index equals to, if length of L1, my bad, length of L1 we used to take, right? Length of L1 equal to index. When the length is 0, the initial index will equal to be 0. And of course, this is going to give us the answer. We can just return false. So that just means that we have reached to the end of our array. Okay. Then what we can do is answer from recursion. Okay, let us call it in small output, small answer, or answer from recursion. We just have to call this L1 x and index plus 1. And now again, very important step. We will assume that we have gotten our answer. Okay, we have actually got our answer. This thing is the biggest step in understanding recursion quotient. Now there are two things which we can do. Okay, there are two things. If recursion says that, hey, I have got the answer. If recursion says that, hey, I am able to get my answer. What we can do is we can return the answer. Okay, so we can just return true. But else, in the case when recursion has not gotten the answer, we cannot return true directly. We have to make sure that we check on the index we are on for this particular element. If it is, then we can return true, or else we can return false. Okay, so I hope this thing is clear. Easy code comparatively. And now if let me run this, and we are able to see the answer is true because we have found our element. If I run it for, let's say 10, the answer is false. So this seems to be working. Now, just one thing I would like to also discuss with you on how we can make this code a little bit more better, or I would say less bulkier. Although I personally don't believe or would advise you to work on making your code always less bulkier. But yes, in cases where it is very easy to understand, it is always better. So what I can actually do is I can do something like this as well. Index equals to x, or whatever answer I have got from recursion. So I can do this as well, right? Let me comment all this and pay attention. Now, how can I say that thing which I'm doing on line 25, this is exactly same as this? Well, if you will actually focus, I am just checking if the element which I am on, that is equal to x or not, or I am just returning the answer from recursion. So if both are false, this will be false, of course. That is something which were happening earlier as well, right? So if this is also not true and this is also not true, then we were returning false. And if I am able to find the element, or if recursion is able to find the element, so if either of them is true, then I can return true directly. Okay, so that's the reason we can just return like this, and we will get our answer. Okay, so I hope this is clear. Let me just quickly run it for you all in this as well. So pay attention. Let me just make it 2. That will be helpful. Okay. So see, the very first thing is that we are going to send our L1 in this particular function. L1 is this, index is 0 and x is 2. Now let us move forward. Of course, all of them are going to make the call, and till the end the calls are going to get made. Okay, so all these functions, they are going to make these calls. Okay. So see, now when the index was 7, we actually reached out to this base case, and we are saying that of course I have actually reached to the end of the array or list, and I have not found my element. So good, makes sense. We can return false, right? Great. So we have returned false. Now once this answer from recursion is false, I'm going to now check for L1 of index. Okay, so see, answer from recursion in this particular case is false. L1 of index 6, is it 2? I don't think, it's 8, right? So we are going to return false again. And the next function, this one with index 5, is going to get false as an answer. Now answer from recursion is false here. Index is 5, and at 5 index it is equal to 5, not equal to 2. So let us move forward, and this is also going to be false, right? Now pay attention. Now index at 4 and our element is 2. Yes, this is okay. No, this is still not equal. Sorry, it is 6. So again we are going to return false. Okay. Now if you will see in this particular call where my index is 3, my element to find is 2, and I'm getting answer as false. This time, because this is going to be true, I'm going to return true, right? This time I'm going to return true, and pay attention. I'm going to return true here. See, true. Now answer from recursion for this particular call when index is 2, we are getting answer is equal to 2 from below. So we are just going to check still, but we are going to return true because it is OR here, right? So we are going to return true, true, and we are going to come out with the final answer as true, which we can print. Okay. So I hope this is clear, everyone. Again, this is a pretty easy code only. We have already done questions with respect to that first and last index where something like this was already getting used. Now, one thing as a, I would say, optimization of this can be something like this. So for I in range, let's say if I make a very big number like this, and instead if I pass this L1, okay, so I hope now you all know what's going to happen, right? I'm going to get recursion length exceeded, right? Maximum recursion depth exceeded. Now the reason for that, again, the reason for that is that we are first calling recursion, and though logically there is no problem in that, what I could have actually done is, instead of calling recursion first, I could have actually done the comparison at my end. And if it is false, then only I should have called recursion, right? So pay attention. Now, if let's say I have 10 lakh students sending in somewhere, okay, let's assume, and the student which I'm looking for, it's on the first, he's on the second position only. Do I need to actually go back to all the 10 lakh students? I don't feel that is necessary. So in this case, and let me actually do one thing, let me make it better because that will be helpful for your notes. So 1 second. So what I'm saying is, let me just define this function recursion better. And instead of actually doing all this, what we can just do is, we can initially do our work where if L1 of index is equals to X, I can return true. Else, I can just return whatever recursion is giving the answer. If it is able to find, good. If not, I'm fine with that as well. And now, pay attention everyone. And now, if I call recursion better here with this particular L1, where it is having so many elements, this is gonna work. See, I'm getting true. Now, I hope all of you understand what exactly have changed here. Let me just show you this using 1 second. Yeah, let us just see this using Python tutor as well, because that is going to help you visualize properly. And again, everyone, I'm making sure that I'm showing you all this visualization, because once you understand all these visually, then believe me, you will never make a mistake, right? So let us see this, everyone. Now what's going to happen, of course, first the functions are going to get defined and we are going to call. It's going to check for the base case. I am first checking directly. I am first doing my work. So if index of 0, is it 2? No. So let us move forward. Again, index of 1, is it 2? No. Let us move forward. Index of 2, which is equal to 3, it is still not equal to 2. Let us move forward. And finally, now pay attention. X is equals to 2, index is 3. I am able to get, now it doesn't matter if I have even 1000 or even lakhs of elements after this particular call, because my whole aim was to find if the element exists or not. Now again, this kind of, I would say, optimization is not always possible. We have to understand from where the question is coming. If I would have to find the last index, then of course I could not have done this, right? I could not have done this. So because I have to just find if it is available or not, I found it in the line number 6 for this particular function. I don't need to make the future calls. I'm able to return true here and everything is gonna work. See, and I'm able to get my answer as true. So these are the little optimization which I would like you to actually focus on while you're writing your code, while you're doing recursion or any DSA question, be it on any coding platform or be it on any mock interviews or when you're giving interviews as well. The more you will be aware about these small optimization, the way you can make better your code, the better software developer and better, I would say, companies and rounds you will be able to crack. Because this is the major difference between students who practice a lot and between those who just think of finding the answer. I want you all to make your understanding and your thought regarding coding clear instead of just chasing around the answer. Okay. So cool then everyone. I hope with that this is clear. You are able to understand linear search exactly using recursion. Yes, we have done the same using iteration as well, but through this video, I am assuming that I should have made the same using recursion a lot more clear. In future, I would also suggest that any questions which we have done using iteration, right, in the past, just go back and also see if the same can be done using recursion. You can or cannot write the code for that, though I will suggest to do if you have time. But that understanding is a lot helpful because many companies, they also focus on asking the common questions and ask you to do it via iteration or recursion and vice versa, right? So maybe you have the approach in mind of just recursion and they can ask you to do it iteratively as well. Okay. So great then everyone. I hope that was clear. Now in the next video, we are going to continue our discussion and learn about binary search and how we can use the same, do the same using recursion. Okay. Thanks a lot everyone. Let's meet in the next video.